Good morning, students. This lesson is of class 9th for the subject of physics, topic lens and refraction of light through a lens, which is covered in chapter 5, refraction through a lens. And this particular topic is on page number 103 of your textbook titled Concise Physics by Selena Publications and is being submitted to you on 30th November 2020. All students may now open page number 103 in front of you. Now students, coming to the first topic, that is lens. Where have you heard the word lens and for what purpose they are used? So students, lens are mainly used in spectacles and camera. It is used to see an object. Various places where lenses are usually camera. It is also used in magnifying glasses and projectors. Nowadays, you are using door spy holes where you can see who is standing outside of your house. So those door spy holes are also constitutes a lens. Spectacles. In spectacles also, we are using lens. Microscopes, torch, binoculars, telescopes. These are certain areas where lens is used to view an object. So students, what is a lens? A lens is a transparent refracting medium bounded by either two spherical surfaces or one spherical surface and the other surface is plane. So students, lens is a transparent surface. It is not silvered from any side as we have silvered in case of mirrors. So lens is a transparent refracting medium bounded by either two spherical surfaces or one spherical surface and the other surface is plane. Students, lenses are of two kinds, convex lens and concave lens. So convex lens is also known as converging lens and concave lens is known as diverging lens. Students, pay attention. In case of mirrors, concave mirror was known as converging mirror, while convex mirror was diverging mirror. So in case of lens, it is opposite. Convex lens is converging lens, while concave lens is diverging lens. Now coming to the first lens, that is convex lens. Students, in convex lens, it is thick in its middle and thin at the periphery. So it is thick in its middle and thin at the periphery. Students, periphery means at the corners A lens which bulges out in the middle is a convex lens. It is further characterized into three types. So the first type of convex lens is also known as biconvex or double convex or equiconvex, which is shown in the diagram drawn on the right hand side of page number 1 of the notes sent to you on 30th November 2020. Here you can see two curved surfaces on the left and right side such that the middle part of the convex lens is thicker as compared to its peripheries. The second part is plano-convex lens. Students, in plano-convex lens, as the name suggests, one surface is convex while the other surface is plane. So, plano-convex lens means one side is plane and the one side is convex. Coming to the third category, that is concavo-convex lens. Students, here, one side is convex while the other side is concave. It is not plane from the other side, rather it is concave on the other side. Students, if you note all the three diagrams of convex lens, the middle part is thicker than its periphery. In biconvex lens also, in plano-convex lens also, and in concavo-convex lens also, the middle part is thicker than its corners or the peripheries. So students, now let us study the convergent action of convex lens. Refraction of light can be understood very easily in a lens by considering the lens to be made up of rectangular slab at the center and one prism on the either side of it. Students, in convex lens, we can say that there are two prisms as placed in figure number 1. The first prism at the top is kept as it is, while the second prism below is kept in inverted manner. Inverted means it is put opposite as compared to the first prism. The base of the prism is inward in case of prism 2, while the base of the prism 1 is towards the glass slab. So now students, what happens here? Suppose the ray of light A, B and C are incident on the lens. Light B is normally incident on the glass slab. In case of normal incidence, the light will not bend in any direction. Rather, it will follow the same straight path. So ray B is coming as it is to the other side of the glass slab without change in its path. For ray B, refraction is occurring, but the ray is not changing its path because it is a case of normal incidence. While let us see what happens to ray A. Now students, in case of ray A, the light is incident on prism number 1. Now let us draw a normal on prism number 1 first surface. Now the incident ray which was falling on the prism will bend towards the base of the prism. Because the light is going from air to glass, it will bend towards the normal. And then let us draw a normal on the second surface of prism 1. Then the ray of light is going from glass to air. When the light is going from glass to air, it bends away from the normal such that the ray is striking the point F, where point F is known as focus. Similarly, if we see ray coming through the second prism, ray C. Now let us draw first a normal on the first surface of the prism. The ray will bend towards the normal since light is going from denser medium to rarer medium on the second surface. The light, instead of going as it is, will bend away from the normal drawn on the second surface. It is the same refraction we did in prism. So students, just pay attention to the arrows. Incident light is going from one medium to another. The arrows has to be shown in forward direction. Since all the rays are meeting at point F, all the refracted rays are meeting at point F. All the rays are coming together at point F. So this action of the lens is known as converging action, which means that the convex lens acts as a converging lens. So students, it can be seen in figure number 1, the set of prisms forming a convex lens converges or brings the rays closer. The parallel rays which were incident on the lens are brought closer to a point F, which is also known as focus of the lens. Thus, a convex lens has a converging action on the incident light rays. Coming to the second type of lens, that is concave lens. A concave lens is thick at its periphery and thin in the middle. In other words, a lens which is bent inwards. It is bent inwards in the middle is a concave lens. Such a lens diverges the light rays incident on it, so it is also called a diverging lens. Students, a concave lens can also be further categorized into 3 kinds. Number 1, a biconcave or double concave or a equiconcave lens. In a biconcave lens, both the surfaces are concaved. And if you can see the diagram shown in a joining figure, we can see that a concave lens is thin at its middle while it is thicker at its periphery. Coming to plano-concave lens, in plano-concave lens, one side is concave while the other side is plane. So it refers to a plano-concave lens. While in convexo-concave lens, one side is convex and the other side is concave. So convexo-concave means one side we are taking, first side is concave, and the other side is convex. So it is a convexo-concave lens. Students, let us study the divergent action of a concave lens. Now, a concave lens in its upper part has a prism in inverted form. Inverted form means its base is upward, while in the lowest part it has a prism with its base downwards. So again we are having two prisms kept at the extreme ends, and in between the prism we are having a glass slab. Now students, again we will take the three rays, and all the three rays incident on the prism are parallel to each other. Ray B is a case of normal incidence on glass slab such that it will go in the glass slab and then emerges out of it without getting deviated to its position, since it is a case of normal incidence. While if we take the ray A, now when ray A is incident on the first part of the prism, let us first draw a normal on the first phase of prism. The ray of light A will bend towards the prism, towards the normal. Why? Because the light is going from rarer to denser medium. And when this light is incident on the second phase of the prism, then the light will further move away from the normal, since the light is going from denser to rarer medium. Now students, the light which is emerging out of the prism, it is moving away from the central line. It is not coming towards the center, rather it is going away from the central line. So let us produce this line backward. If we produce the emergent line backward, you will see a point where this line is meeting the central line, and we will take that point as point F, that is focus. So students, the line emerging out of the prism is actually meeting at point F. The backward production has to be shown dotted. Now let us see what happens to the ray C. Again, when ray C is incident on the first surface of the prism, the ray will bend away from the central part of the prism, as it has to go from rarer medium to denser medium. The ray bends towards the normal, or you can say the ray bends towards the base of the prism also. So students, when the ray strikes the second surface of the prism, now it has to go from denser medium to rarer medium. Again, the light will bend away from the normal. Now this emergent ray has to be produced backward in the same manner, and you will see that there is a point F where your first ray was also intersecting. So the ray A and ray C after refraction are going away from the lens, while if we produce them backward, it seems they are meeting at one point, and that point is known as focus. Students, kindly see the emerging rays, finally emerging rays are basically spreading away from the lens. And if these are going away from lens, such rays are known as diverging rays. So it can be said that the concave lens acts as a diverging lens. Now students, let us study certain technical terms related to a lens. First term is center of curvature. Students, a lens has two spherical surfaces and hence it has two center of curvature, which can be defined as center of the sphere whose part is the lens surface. For example, if we are having a convex lens, in case of a convex lens, there are two spherical surfaces overlapping each other. So the center of the first lens will be written as C1, while the center of the other lens can be written as C2. So when these two bounded spherical surfaces are taken, we form a lens. So a lens is having two center of curvatures on either side of it. For further clarity, students, kindly open page number 105 of your book and see figure 5.7. Here you can see C1 and C2 are two center of curvatures taken in case of both concave as well as convex lens. Now students, coming to the second term, that is a principal axis. A principal axis is the line joining the centers of curvature of the two surfaces of the lens. Now, for example, if you are having a convex lens, in case of convex lens, you are having two center of curvatures at both the surfaces on left and right side. So students, if we draw a line between C1 and C2, that line is known as principal axis. So the line joining the two center of curvature in case of both convex and concave lens is known as principal axis. The third point is optical center. It is a point on the principal axis of the lens such that a ray of light passing through this point emerges parallel to its direction of incidence. Students, optical center is a point on the principal axis of the lens such that whenever a ray of light is passing through this point, the light emerges parallel to its direction of incidence. And it is shown in figure 5.8 on page number 106 of your physics textbook. Students, when we are doing the questions, we will be considering the lens to be thin, such that the lateral shift, which was done in chapter 4 also, the lateral shift of the emergent ray can be ignored. So thus, a ray of light directed towards the optical center of a thin lens can be considered to pass through the lens undeviated and undisplaced. Students, see figure number 3 drawn on page number 4 of the notes sent to you on 30th November 2020. We will be drawing this case in our ray diagrams also. We will be considering the lens to be thin, and in such case, a ray of light incident on the optical center will pass as it is to the next medium without getting deviated. That is, it will not change its position. Whatever was its incident position, the same will be its emergent position. Coming to the fourth term, principal foci. So students, a light ray can enter a lens from either side. As lens was transparent from both sides, so a light ray can enter a lens from either side. Therefore, a lens has two principal foci, one on either side of the lens, and are known as first focal point F1 and second focal point F2. Students, note that if the medium is same on either side of the lens, that is, if lens is placed in air such that on both sides of the lens, the medium is same, that is air. So if the medium is same on either side of the lens, then the two foci are situated at equal distances from the optical center. Now students, let us study about first focal point, and we will study it for both cases, that is for a convex lens as well as a concave lens. So for a convex lens, first focal point is a point on the principal axis of the lens such that the rays of light coming from it, so the rays of light are coming from first focus, so the rays of light coming from it after refraction through the surface of the lens, after refraction through the surface of the lens, the rays becomes parallel to the principal axis of the lens. So see figure 4a, in which I have shown you F1 as the first focal point. The light incident from first focal point after reaching the central part of the convex lens becomes parallel to the principal axis.